let's look at the model for joint variation. In words, we say Z is jointly proportional to X and Y. Or I could say Z varies jointly as X and Y. So there's various ways of saying it. But in words, you're going to see the word jointly. The model is going to be Z is K times X, Y. Whereas it varies jointly. X and Y together influence Z. Again, K is your constant of proportionality. So for any given situation, K will remain constant. I'm going to give you a 4-step method to solve any variation problem that you encounter. So to solve variation problems, the first thing you do is write the variation model. So you want to know, do I have direct variation? In which case you're going to multiply K times the variable. Do I have inverse variation? In which case you're going to do K divided by the variable. Or do I have joint, in which there will be two variables that you multiply, in this K times that product. So do you have direct, inverse, or joint? That's what you're asking yourself in writing the model. Once you write the model, you're going to use the given information to solve for K. K will be constant for the given problem. So you use the information and solve for K. K now becomes constant for that particular situation. Once you know what K is, you can rewrite your model that you developed in step 1, substituting the value of K that you got from step 2 for the letter K. So up here your model will have a K in it. Once you finish 3, the model will not have a K. The model will have the value of K. Whereas what you do here is you replace K by a number. Once we rewrite the model as a formula, I'll say, then we are going to substitute the information given in the question. So go to your question, look for the information, and we're going to substitute into the final variation model, which was step 3. And once we get through doing the substitutions, we simply solve for the unknown. So that would be solving equations as you've been doing for the last few lessons. Let's look at an example. The amount of gas used by car is directly related to the number of miles driven. Now think about why it would be directly related. As you drive more miles, you use more gas. If a car traveled 320 miles on 13.8 gallons of gas, how far can the car travel on 20 gallons of gas? So we have a direct variation problem. The constant in this particular problem will be how far this car can go on a gallon of gas. So the situation in this case would be this car. Now, of course, if you change cars, you no longer have the same situation. You'll need to keep referring back to the problem as we set it up. So I'm going to assign variables first. I'm going to let D equal distance traveled and G equal number of gallons of gas. So D will stand for the distance we travel. G will be the number of gallons of gas. Now let's look at step 1 and write the proportion. The distance is directly related to the number of gallons of gas. So this is your model for direct variation. The variable is equal to K times the related variable. The distance is K times the gallons of gas. Now we want to use the information to solve for K. Well, let's go back and see what we see in the problem. The car traveled 320 miles on 13.8 gallons. So what I'm going to do is replace D by 320 and G by the 13.8 gallons. 320 miles on 13.8 gallons. The problem gave me that. So I know that this particular car traveled 320 miles on 13.8 gallons of gas. Now, of course, I can solve for K, just solving the equation. So what I need to do to get K by itself is to divide both sides by the coefficient of K, which is 13.8. And dividing 13.8 by 13.8 gives me 1, and 1 times K gives K. If you take your calculator, and you probably want to do this to make sure I did the math right, take your calculator and divide 320 by 13.8. Now the answer did not come out to be exactly 23.2. I did round off. But rounded to tenths, K would be 23.2. Now for this particular car, K is a constant. What this means is this car gets 23.2 miles per gallon. So that's the K for this problem. But I needed a measurement to get that. So now I know the car gets 23.2 gallons of gas. Now step 3 says replace K from step 1 with the number I got. So I just go back and I rewrite my model, but I substitute the 23.2 in place of K. So I don't write K the second time, I write 23.2. I still write D, I still write G. But I know that for this car, the miles per gallon is a constant 23.2, so in place of K I write 23.2. Step 4 said go to the question and substitute values of D and G and solve for the unknown. Let's go to the question now. How far can the car travel on 20 gallons of gas? So that means, what is D when G is 20? So I replace G by 20 and solve for D. So bring down the D, that's still my variable. The 23.2 is the K, but in the place of G I write 20 because the question said, how far can the car travel on 20 gallons of gas? Now to solve the equation, all we need to do is to multiply 23.2 times 20, and we get 464. So to answer the question, the car can travel 464 miles on 20 gallons of gas. Now some of you are probably saying, oh come on, give me a hard one. That one was too easy. Well, you asked for it. Here comes one.